Alright, today we're going to be taking a look at the screw and making sure that we model it so that we can throw it into an assembly, use our view tab, section view, and then we can start looking at our screw mounting points to make sure that that screw is slightly bigger than the hole that we're going to use, and definitely our thread digging into the sidewalls here to make sure that it's going to be a great fit. So what we're going to do, create a new part file. We're going to create a sketch on the front plane, just like we normally would. We're going to be revolving this screw part. So we're just going to be going straight up here. I'm going to use some rectangles. Our screw kind of looks something like that. We're going to need a couple different dimensions here. So we need this dimension. We'll need this dimension. This dimension will be a little bit of an estimate. It's going to be rounding up here. We'll have a little dome piece up here eventually, but we're going to fillet these first and then add in our little arc to round off the top of the machine screw. So looking at this, there's a few things that we can do. This right here is 0.75. That's what the box says. Right here is going to be the shaft of the screw, not the thread. So let's get a measurement on that. We'll go up here at the dial calipers. Try to measure as best we can. It'll be slightly at an angle, and that's fine. Now, when you model this, you want to try to be as precise as possible. We have 0.13. Try to measure it, get to the nearest thousandth if you can. This is diameter. We need a radius, so I'm going to divide it by 2. I'm going to do the same thing for the top here. Again, this is a little bit of an estimate. So if I'm going in here, I'm going to use kind of like a step dimension and line it up by the top as best as I can. This seems to be 0.1. Perfect. Next thing we're going to do, looking at the shape of our screw. The shape of our screw right up here, this is a pan head, so it's nice and flat here. But right on the edge right here, it's a little flat. So we have a little bit of an arc right here. Then we have this dome that we're going to add in for our revolve. So how I'm going to approach it, I'm going to use the fillet tool, and I'm going to play around with some numbers. I want to fillet this line and this line, this line and that line, and I should have a little bit of a flat gap right here. I'm going to use a small number to start off with just to see if it's going to work. Alright, so this is extremely small, so Control Z, undo those. Use a little bit larger number now. We'll do 0.05. Oh, okay. So this barely fit. They are connected. So what we're going to do, we're going to use a slightly lower number than that. It's like I can also get this number by taking our distance here, divided by 2, and just adjust it by a couple thousandths, which is what I'm doing right now. Alright, now that I have that, our next part, we have a little dome piece. This dome piece, if I measure the top of my bolt, it goes up 0.02. I'm going to use the 3-point arc tool, go off the top, click on the fillet here, but I'm trying not to get a midpoint or a snap point, no green dots, just off to the side here. Now this arc, I don't necessarily know what it is, but I know that it needs to be tangent to this arc. I'm also just going to grab this arc and stretch it out so it's a little bit flatter here. That would be great to do. Alright, one other dimension we forgot to do, we need the radius of our pan head. So measuring that real quick. Looks to be 0.315. 0.315. Now this is diameter. I need radius, so I'm going to divide it by 2. Perfect. Now I can go up here and I can trim out these shapes. It does make it easier to do our revolve, especially a little bit later on. If you're having troubles trim, you might need to delete a line first. Alright, the next thing. This screw makes a point down here. So there's a couple different ways I could do that. I'm going to use the chamfer tool. Chamfer tool wise, I'm going to use that distance down there, the 0.065. We're going to chamfer these two edges here. It should make a point. Alright, looks pretty good. We're going to finish the sketch. And we're going to revolve this thing. We've got a little axis right here. Great. We got our bolt. Next part, we need to make the Phillips head on top here. To do that, I'm going to go to the origin, and I'm going to find a parallel plane to the bolt head. I'm going to offset a plane from here, and I'm just going to drag it so that it's slightly above. The distance here doesn't really matter too much. I'm using 0.875. From here, I'm going to create a sketch up on top. And then I'm going to use my 2-point center rectangle. I'm going to go off the origin. I'm going to make that little plus sign. Hey, go ahead. Measure this as best as you can. It's going to be a rough estimate. This up here is more of an appearance thing than it is a needing to be absolutely precise. And update it. Dimension it. Alright, from here, the extrusion. Depth-wise, we don't really have a way to measure that, so we're just going to go about halfway or so into the pan head. If I'm looking at the side here, about halfway. Looks great. We'll hit OK. The work plane is still there, so I'm going to right-click and hit visibility. And there's our little bolt head. Next thing, we're going to add the threads. This one is probably the more complicated thing. What we'll need to do, we're going to go to the origin folder. We're going to find a intersecting plane, like the front plane, and we're going to create a sketch on it. We're looking at this object in the middle, so I'm going to right-click the model and hit Slice Graphics. This is where I'm at inside of that model. From here, I'm going to project geometry the edge so I can build off of it. And we're going to create the thread. The thread is just a little triangle shape. And I'm going to be using a tool called Coil, so I do need an axis. So I'm just going to go off the midpoint here and just draw a straight line down. There's other ways to do it, and we'll look at that too. This little triangle, I'm going to make sure that the peaks are 45 degrees as best as I can. So I'm just going to go up here, make this 22.5, that's half of 45. I'm going to do the same thing to the other one here. There's other ways to do it, but this one's a little more consistent. This little line, our chord, we're going to make it 0.03. If I'm measuring the thread from side to side for diameter, I would be able to subtract our inner core here, and that would give me this number roughly. The next thing I would do is measure from the bottom of the pan head to the top of our first thread, and it seems to be 0.04. Now our chord right here, I'm actually going to go up here, click on it, and click the construction line. It just makes it easier to model a little bit later. I'm going to hit finish. And get kind of a view so I can see what it's going to do. I'm going to hit coil. I'm going to select my shape, select my axis right there in the center. And then what I would need to do for pitch, I could actually measure from the top of each thread to the next one to get this rough number. For me, it was about 0.07. Revolution-wise, I could literally count how many threads there are and get a rough estimate. When we get to about this point down here, this is where we want our coil to end. So your number might vary slightly. I'm also adding a -1 degree taper so that it kind of thins off towards the bottom here. Once I'm happy with what my projected coil is, I'm going to hit OK. From here, to finalize everything, I could actually go up here and assign it a material. These are steel, so I can use like a mild steel or even like a galvanized to get a nice appearance on my part. And this is everything we need to know for our machine screw. This is, again, a great part to throw into our assembly and use section views to see how they're actually going to be modeled. So we can go up here, get about a half view with our section view tool, and now I can see how this is going to interact. And this is going to give me more information to model this a little more successfully. Good luck!